let's take a look at 7-5, factoring special products. We've done lots of factoring already. We've done binomials, groupings. We've done Daniel's method. We did quadratic trinomials. We're going to look at a couple now that are just called special products. Let's start with perfect squares. A trinomial is a perfect square if the first and last terms are perfect squares. In this case, 9 is a perfect square of 3. X squared is a perfect square of x. 4 is a perfect square using 2's. And that's not the only stipulation. 2 stipulations. And the middle term must be 2 times the product of the root of the first term and the second term. So I have 2 times 3x times 2. If that equals 12x, then I have a perfect square. In this case, it does. 3x times 2 is 6x. 6x times 2 is 12x. Therefore, I have 3x plus 2 times 3x plus 2, which is 3x plus 2 squared. I have a perfect square trinomial. At first, you might think, oh my gosh, that's a lot to remember, but it makes it fast, so you will remember it. You are looking for perfect squares. Let's try some. Option 1, I have here x squared plus 12x plus 36. Is x squared a perfect square? Yes, it is. X times x. Is 36 a perfect square? Yes, it is. 6 times 6. Now take the 2 times x times 6. Remember, multiplication is all one string. The order doesn't matter. The parentheses don't matter. None of it matters. It could just say 2 times x times 6. If that equals 12x, you have a perfect square. And it does. Therefore, x plus 6 squared. You're taking the root from each term. Option 2, you could just put it together and say, does this work? X squared plus 2 times x times 6 plus 6 squared. Does that work? This should say x, not x squared, right? So that means I have an error, which I'm going to fix real fast before I forget to fix it. There we go. Easy. X plus 2x times 6 plus 6 squared. And I get x plus 6 squared. So yes, a perfect trinomial. Let's try some. So I want you to stop the video, of course, and I want you to look at the screen or write them down. I have 9x squared plus 18x plus 9. Let me do the first one with you. Is 9x squared perfect? It sure is. 3x. So I know that I have 3x. I'll go ahead and type it in. I have 3x. Is 9 a perfect square? It certainly is. It's a 3. So that means 18. Is 18 2 times 3x times 3? Kind of wrote on top of things. Let's move it over. Is that true? 2 times 3x is 6x. 6x times 3 is 18x. Yes, this is going to be a perfect square, a perfect trinomial square. And it'll be 3x plus 3 squared. So you're going to end up with 3x plus 3 squared. Take a look at the next ones and see what you can come up with. Stop the video. Okay, welcome back. Here are your answers. We already saw that the first one was a perfect square. The second one, x squared, of course, is x times x. 16 is 4 times 4. So the big question is 2 times x times 4 equal to 9x? No, it's not. So it is not a perfect square trinomial. Next one, 16x squared. 4x times 4x, yes. 25 is a perfect square. We know that it's either 5 times 5 or negative 5 times negative 5. In this case, because we see this negative b, we're going to have to go with the negative 5. Now, 2 times 4x times negative 5, absolutely, negative 40x. Therefore, my perfect square, 4x minus 5 squared. The last one, 2x squared. So that would be 2x times 2x. So I actually should have had a parentheses in here because this is 2x squared, not just 2 times x squared. There's a little bit of a difference. Sorry. Plus 2 times 2, it's not going to work. I'm not going to get it, am I? Because I can't do a negative 1 is not a perfect square. So there was no point in even trying it because negative 1 is not a perfect square. Easy? Somewhat after you practice. First time around, no, this isn't easy. You need to practice. So that was our first special product, trinomial perfect squares. Let's look at a second one, the difference of two squares. You're going to see this often on a test and in algebra, difference of two squares. In this case, I have a squared minus b squared equals a plus b times a minus b. All right, well, let's see how we figure that out. Number one, the original polynomial has two terms. So two terms only, not a trinomial. It's a binomial. And one is subtracted from the other, and both terms are perfect squares. So here's an example. 4x squared minus 9. 4x squared is perfect. 2x times 2x, 9, 3 times 3. Even though it's a negative 9, it doesn't matter. Two multiplied together, you have a 3 and 3 is 9. So we aren't worried about the negative sign at this moment, the subtraction. What we know is that we have 2x plus 3 and 2x minus 3. Because although 9 is a perfect square, we know that negative 9 is not. That's what makes it the difference of two squares. So I get 2x plus 3 times 2x minus 3. What you find is that you get a positive 6x in the inside and a negative 6x on the outside, which eliminate each other. So we have no middle value. Let's look at some examples here. I have the answers up already, but that's all right because we're trying to do this together. 9p squared is 3p and 3p. 16q squared is 4q and 4q. Now make one positive, one negative, and yes, you have difference of two squares. X and x, 81 is a perfect square of 9s. X plus 9, x minus 9. X to the 6th power is x to the 3rd times x to the 3rd. Yes, it's a perfect square. 7? We all know that 7 is not a perfect square, so this will not work. Try some. Now, hint. Remember the rules for multiplication with exponents. When you have the same base, you add the exponents. So x squared times x squared is not 2x. It is x to the 4th power. I want you to go ahead and stop the video, of course, and I want you to take a look at all three of these. So pause the video, copy down the 3 problems, see what you can do, and then let's move on. So number 1, yes, was difference of two squares. Number 2, Yes, difference of two squares. 49 is a perfect square, and q to the 6th is a perfect square. 3 and 3 plus 3 equals 6. P to the 8th power, I know you look at the number 8 and you say it's not a perfect square, but in exponent rules, it is because 4 plus 4 is 8. Complicated. Nobody said algebra was easy. It is complicated. A lot of rules to remember. That's why we practice. 4x, that's perfect, but 4y, so 4 is perfect, 2 times 2, but y to the 5th, I cannot add 2 of the same value and get a 5. Therefore, it is not a perfect square. That's it for special products. Go ahead and practice and see how you do. Bye now.